Alrighty. We want to make this continuous at 2. We want to extend it. So let's check out what happens when we plug in 2. We get, oh my gosh, 0 over 0. And that means we should be able to cancel out a factor of x minus 2 from the top and the bottom. We already see x minus 2 in the bottom, but up top we have the root x minus root 2. So we're going to have to do some work to get that x minus 2 out of there. And this is very similar to what we did with limits. We're just going to multiply by the conjugate, and that should help us out a little bit. Nope, root x plus root 2. Root x plus root 2. And when we do that, f of x really equals x minus 2 over x minus 2 times root x plus root 2. And now the x minus 2's cancel out. So f of x really equals 1 over root x plus root 2, except for when x is 2. So f of x is really this simple function down here, or the simpler function down here. This is a 2. Except for when x is 2, because at 2, this is undefined. Now, down here, this part is not undefined. I can plug 2 into here, and I'm going to get 1 over root 2 plus root 2. But that's not what f of x equals to 2. f of x was undefined at 2, so we can't just say f equals that number. However, I can create a new function, g of x, and I can just make that an extension of f of x. So I'm going to let g of x, very similar to the other examples, g of x is going to equal f of x, which is 1 over root x plus root 2, as long as x does not equal 2. And then to make it a continuous function, when x is 2, I want g of x to equal 1 over 2 root 2. And the reason that I chose this value is because as x approaches 2 on f of x, we get 1 over 2 root 2. So now for g of x, the limit as x goes to 2 of g of x is 1 over 2 root 2. Because if you're on this function, you're on this part up here as you approach 2, and since this equals 1 over 2 root 2, then it should be approaching 1 over 2 root 2, and it is. And I just said, hey, guess what? G of 2 has to equal that.